Hi all, this is an example of solving a radical equation. You know you're working on a radical equation when you have variables stuck under a radical. So in this case, the fact that we have a y stuck in the square root is a big sign that we're dealing with a radical equation. Our goal, as usual, is to turn it into a simpler type of equation, so either a linear or a quadratic equation. The way to try and do that is to try and get rid of the square root, and we get rid of square roots by squaring. So we would like to square both sides of the equation, but we want to be really thoughtful about when we do that. If we go ahead right now and square both sides of the equation, we actually end up with kind of a huge mess. I'm just going to go into this a little bit to make sure you're all convinced that this is not the greatest idea. Y squared is wonderful, but if you're going to square a 2 plus the square root of 16 minus 3y, that means multiply it by itself. I don't want to see anybody distributing that second power in. Distributing says if you have a sum or difference and you try and multiply by something, you can multiply the two terms individually. This is not multiplying by something, this is squaring something, so we have to make sure we're really thoughtful about what that means. If you're trying to multiply this thing by itself, this is a binomial expression, but multiplied by a binomial expression, we're going to end up foiling, and this is where we start to get into some trouble. The first part of FOIL is great. 2 times 2 is 4, no problem. The outside inside are a mess. I get 2 times the square root of 16 minus 3y for my outside term, and I get another 2 times the square root of 16 minus 3y for my inside term. The last actually works out nicely as well. I get the square root of 16 minus 3y multiplied by itself. So we're getting the square root of 16 minus 3y squared, which just leaves us with the 16 minus 3y. Okay, so really important that you realize that it is not okay to distribute the second power in. That doesn't work. You have to multiply by the entire thing by itself. And also really important to recognize that when you do that, you're not going to eliminate the square roots, which completely defeats the purpose of squaring both sides. We square both sides to eliminate roots. So I actually want to go back to the beginning. Sorry for the tangent, but I want you to be really convinced that this is not going to work. That doesn't mean squaring both sides is completely a bad idea. It just means we want to rearrange a little before we do it. So if you're going to try and eliminate a radical by squaring both sides, you should make sure you isolate the radical first. So all we really need to do is subtract 2 from both sides of the equation. And now we're beautifully set up to square both sides and see what happens. So if I square both sides of the equation, the radical disappears immediately. I don't have all the messy work that I had on the right-hand side. I do have a little bit more mess on the left-hand side, so I want to make sure that I'm really careful. I still have to FOIL, but what I'm foiling is a lot less messy and does not leave me with any square roots. So I have a y squared minus 4y plus 4 equal to 16 minus 3y. And this is no longer a radical equation. I've successfully turned it into a quadratic equation. So I'm going to go ahead and try and set it equal to 0, which means I need to add a 3y to both sides. So I'll have a y squared minus y. And I'm also going to go ahead and subtract 16 from both sides in this same step. Okay, so y squared minus y minus 12 equals 0. Let's see if we can factor. Again, they're not always factorable. If you can't factor, it's fine to use a quadratic formula. But that 12 is looking pretty promising to me. So I'm going to split up the y squared, make it a y and a y. And then I want factors of negative 12, and I'm hoping to choose them in a way that make my inside outside a negative y. So 4 and 3 are looking like really good ideas. And if I choose the negative 4, positive 3 combo, my outside will be a 3y, my inside will be a negative 4y, and that does in fact add up to negative y. So this looks perfect. Now that I have a product set equal to 0, I can go ahead and make that even simpler by splitting it up into 2 linear equations. Y minus 4 must equal 0, or y plus 3 must equal 0, which means y must equal 4 or y must equal -3. Radical is another type of equation that can end up with extraneous solutions, so we're going to be really careful here. In this case, it was squaring both sides of equation that can introduce extra solutions. If I square both sides, all of a sudden things that weren't equal might become equal because I lose track of a lot of negative sign information. So we want to check these, and we have to be a little more careful. It's not quite as immediately obvious as it was with rational. So if I want to check y equals 4, I am going to try to decide if 4 is in fact equal to 2 plus the square root of 16 minus 3 times 4, which is 12. So is 4 in fact equal to 2 plus the square root of 4? This looks great to me. Square root of 4 is 2. 2 plus 2 is in fact 4. So I think y equals 4 looks good. We should also check y equals -3. And this time, that ends up looking like -3 equal to 2 plus the square root of 16 minus 3 times -3, so that ends up being 16 plus 9. This already is looking bad, but let me just carry it through a little bit further. So I'm a little concerned having a negative sign over here, the -3, because this is a positive root. There is no plus minus here. Don't get confused. If you introduce a square root into a problem to eliminate a square, then you will need a plus or minus. But if it's already sitting there, it should clearly tell you I am a positive root or I am a negative root. So this is a positive root. If I take the positive root of something and then add 2, it's going to be really hard for me to get a negative answer. In fact, impossible. But if you don't spot it right away, you can go a step further. Is it true that -3 is equal to 2 plus the square root of 25? 2 plus 5? Absolutely not. Notice what is actually kind of a good sign for us is if this was minus the square root of 25, it would work. So if you could just decide that was a negative root, this would be a true statement. That's an indicator that the problem really is with the squaring both sides. If we squared both sides, we could make this work out and be true. But without squaring both sides, we're in trouble. So we do not keep the y equals -3. We do keep the y equals 4. All right, that's it.